introduction to algorithm analysis. So, before moving on to algorithm analysis, what is by algorithm? So, algorithm is actually a finite sequence of instructions or steps if followed will accomplish a particular task. So, when we follow that sequence of finite sequence of instructions, that will give some output or that will accomplish a particular task. Now, what are the properties or characteristics of a good algorithm? First one is input. So, input in the sense, if you take any algorithm, an algorithm must receive 0 or more inputs. That is one property. And second one, output. So, if you take any algorithm, the algorithm must generate one or more outputs. In the sense, if you are having an algorithm without that isn't generating any output, then that algorithm is basically useless. So, a good algorithm should generate one or more output. So, if you take an algorithm, it will receive 0 or more inputs and generate one or more output. Then, third property or third characteristic is, or we can say, definiteness. Definiteness. So, definiteness means each and every steps or instructions in the algorithm must be simple and unambiguous. Or simple and unambiguous in the sense, each and every instruction must be simple and clear. So, a third person, it must be easier for the third person to understand the algorithm. So, each and every steps must be simple and unambiguous. That is what you mean by definiteness. Then fourth one is finiteness. So, finiteness means if you take an algorithm and try to work out that algorithm by giving the prescribed valid input, the algorithm must terminate within a finite sequence of, or by executing finite sequence of instruction. Or I can say that the algorithm must terminate within a finite amount of time. That is what you mean by finiteness. So, if we try to work out the algorithm for a valid input, for a given input, the algorithm must terminate within a finite sequence of steps. That is what you mean by finiteness. Then the fifth one, effectiveness. Effectiveness. So, effectiveness means each and every instructions or the steps given in the algorithm must be basic one, and if you work out the algorithm, work out that step using pen and paper, that step must generate some effect on the corresponding input received. So, that is what you mean by effectiveness. Each and every step must be basic so that it must affect the input received. So, these are the main characteristics of an algorithm. And if you consider the study of algorithms, so study of algorithms actually involves important areas of research. It includes different important areas of research, and these are some of the important areas. So, first one is how to devise an algorithm. So, assume that you are having a particular problem. So, let it be the non-problem sorting. So, you have to sort a sequence of a set of integers, a collection of integers. So, for that problem, you can have different algorithms, but the approach followed by, or the technique followed by each algorithm or all these algorithms need not be same. In the sense, in order to solve a particular problem, you can have different algorithm design techniques. So we can apply different techniques to solve a particular problem, different algorithm design techniques to devise an algorithm that solves the problem. So for example, if you consider quicksort algorithm or merge sort algorithm, those algorithms actually follows divide and conquer strategy. Again, if you consider some other, for example, the algorithm that solves minimum spanning tree problem, there it actually follows, or the design technique is greedy strategy. So we are having different algorithm design techniques: divide and conquer, dynamic programming, greedy strategy, etc. So based on those design techniques, we can devise different algorithms to solve the problem. So one important research area is how to devise an algorithm to solve a particular problem. So we will be having different algorithm design techniques, and we will be discussing all those algorithm design techniques in our algorithm analysis course. So first thing is how to devise or design an algorithm. Then once after designing an algorithm, the second headache is to show that your algorithm works properly. So second concern is how to validate an algorithm. So how will you ensure validity? Validity means for all possible valid inputs, your algorithm generates correct output. So you have to show that. But if you consider your algorithm that solves a particular problem, the input set need not be finite. In the sense, if the input set is finite, assume that for your algorithm A, you are having only 5 inputs: input 1, input 2, input 3, input 4 and input 5. So for these 5 inputs, you need to work out this algorithm using pen and paper and show that for all the 5 inputs it generates correct output. Then your work is over, your validation process is over, provided the input set is finite. But in practical situation scenario, the input set need not be finite. So the input set will be infinite. So you cannot simply use pen and paper and show that the algorithm generates correct output for some set of inputs. For that, you have to use some formal mechanism, and that mechanism is termed as proof of correctness. Writing proof of correctness. So once after designing the algorithm, you have to formally show that your algorithm is valid or correct by writing proof of correctness. That is the second area of study if you consider algorithms. Then the third one is how to analyze an algorithm. So you are having a problem, you have designed an algorithm that solves the problem. Once after designing the algorithm, you have formally written proof of correctness that validates your algorithm, that shows that your algorithm is valid. So if a third person goes through that proof of correctness, he will be convinced that the algorithm is correct. Then once after writing proof of correctness, then the next task is to analyze your algorithm, analyze the efficiency of your algorithm. So analysis actually involves, so in order to analyze the efficiency can be analyzed in terms of the work done by algorithm, and the second criteria is space taken by algorithm. So work done by the algorithm is determined or represented in terms of time complexity. Time complexity in the sense, work done by your algorithm is actually proportional to time taken by your algorithm. So you can say that work done is actually time complexity of your algorithm, and space taken by the algorithm is termed as space complexity. So you can call these two areas of time complexity analysis and space complexity analysis. So once you are having an algorithm in your hand that is correct, a correct algorithm in your hand, then you have to analyze the efficiency of your algorithm in terms of its time utilization and space utilization. So the best algorithm will take minimum time to generate the output and minimum space to complete its execution. Right. So these are the two important criteria for analyzing the algorithm. So this is one area, and the fourth one is how to validate program, or how to test program. See, you have designed an algorithm to solve a problem, and you have written proof of correctness indicating that your algorithm works properly, and then you have analyzed your algorithm in terms of time complexity and space complexity, and you found that your algorithm is efficient. Then you will go for implementing the algorithm. So you will be having the program in your hand. The next target is to test the program. So testing actually involves two phases. One is debugging, and the other one is profiling. So debugging actually involves running the program or running the code by applying some data set from some set of valid inputs, and you'll be checking whether there exists any runtime issues or any issues in the implementation. If so, you'll be going to correct that implementation. So that is what happens in debugging. In profiling, what happens is you'll be verifying, or you'll be calculating the time taken by your implementation to terminate and space taken by your implementation or the program code to complete execution. So profiling actually involves a runtime calculation of time and space of your algorithm. So these are the four important areas of research when we talk about algorithm. In our algorithm analysis course, we will be focusing on different algorithm design techniques and different techniques to analyze time and space complexities. And again, we will be focusing on time complexity rather than space complexity. When you compare these two, time complexity and space complexity, in some cases we will be focusing on time complexity, some application will be focusing on time complexity rather than space complexity. For example, for real-time systems, space must not be a concern, time will be a concern. So in that case, we will be focusing on time complexity. Again, if you consider some handheld gadgets, there rather than time, space will be a concern. So there we will be focusing on space complexity rather than time complexity. And again, the conclusion is that depending upon the application, we have to work out on this time complexity and space complexity, whether we have to analyze the algorithm and bring down the time complexity or the